Hi, I'm Bill Kinney. This is video number 34 in my series on arithmetic, algebra, and graphing. Part 3 of a sub-series on exponents, roots, and logarithms with an emphasis on calculator usage. In the last video, we ended by looking at a couple abstract properties of exponents, that if you've got a number b and you raise it to the m power, for example, 3 to the second power, b is 3, m is 2, and then you take that number, which in this example was 9, and you raise it to another power that I called n here, that you get the same thing if you take b and raise it to the m times n power. Up here, that was the same thing as taking 3 and raising it to the 2 times 3 power, the 6th power. Another property we saw is that b to the m times b to the n, if you've got them being multiplied like this, that the exponents can be added. You can have b to the m plus n power and get the same thing. Back in this example, I had it with the, right here, I had 3 of them instead of 2 of them. The b is the 3, the m, the n, the o, or the p, or the q, or whatever you want to call the last exponent are all being added here. This is the same as 2 plus 2 plus 2 is 6, same as 3 to the 6th power. When I illustrate that these properties work, even if your b's are fractions. For example, say we were taking 2/3, and we were going to raise 2/3 to the 4th power. What does that mean? It means 2/3 times itself 4 times. What do you do to figure that out? You got to multiply the numerators and you got to multiply the denominators. You've got to, in fact, take 2 to the 4th divided by 3 to the 4th. This is actually illustrating another property of exponents that I'm not going to talk about at the moment, but maybe you want to think about or look up what you think I'm talking about there. But 2 to the 4th is 16. 3 to the 4th is 3 squared is 9, and 27 is 81. Does this work if you check it with a calculator? Yes, though you got to be careful. Calculator, these things could be repeating decimals, and the calculator might not be representing them that way. In fact, it's not. 2/3 is 0.6 repeating. You see a 7 there at the end. It's rounding. In reality, the calculator is storing more places of accuracy than what you see there, but it is treating it ultimately like a truncated decimal. I'm going to raise that to the 4th power. By the way, on this calculator, if I want to take that preceding number and raise it to the 4th power, if I just hit this power key, the caret there, it puts a and s up there, meaning that's referring to the previous answer, the 0.6 repeating there. It put that out there for me automatically. Now I put a 4, hit enter, and I get that. Evidently, that's the decimal representation, or an approximation for it, of 16 over 81. There we go, you'll get the same thing. I haven't illustrated the property yet. What if I took this thing and squared it? Well, it's supposed to be, by the property from a few minutes ago, that I'd multiply these exponents. This should be the same as 2/3 to the 8th power. And it is, because it's the same. I mean, ultimately, if you think about it, 2/3 to the 4th is multiplying 2/3 times itself 4 times. If you square that, you're going to get 4 more copies of 2/3. You're going to get 2/3 8 times, ultimately, 2/3 to the 8th power. So it's got to work by definition, really. As far as the calculation goes, you can do 2 to the 8th divided by 3 to the 8th. 2 to the 8th is 256. 3 to the 8th, if you use your calculator, you should check it on your own here, that's 6,561. That should be the same as 16 over 81 to the 2nd power. And indeed it is. 16 squared is 256. Try it. 81 squared is 6,561. Try it on your calculator. I just tried it on mine. It does work. And, well, again, as far as the other property goes, this example can illustrate it as well, because I can think of this as 2/3 to the 4th times 2/3 to the 4th. The exponents are the same here, but I can add them to get 8 as well. 8 is 2 times 4, but it's also 4 plus 4. So if I think of it this way, then I can imagine adding the exponents to get the 8 here. Either way you do it, it's illustrating the property. I would encourage you to try this with other examples. Make sure that it works. I want to go on to something else here at the end of this video and continue in the next video. First of all, I'm going to just state something that you may know, but you may not know why. I'm not going to explain it right away, but probably in the next video I will. What does it mean to raise a number like 5 to the 0 power? Does it mean multiply 5 times itself 0 times? Well, no, you can't really do that. You can't multiply a number by itself 0 times. That doesn't make any sense. It turns out to be a good idea, for reasons that I will explain, hopefully in the next video or two, to define 5 to the 0 power to equal 1. And in fact, 4 to the 0 power to equal 1, and 3 to the 0 power to equal 1, and 1/2 to the 0 power to equal 1, and 2/7 to the 0 power to equal 1, and even -5 to the 0 power to equal 1. I didn't do negative numbers to a power before, but you can. You know, -5 to the 3rd power would be -5 times -5 times -5. 3 negatives make a negative. This ends up being -125. You can raise negative numbers to powers. In fact, any number to the 0 power except 0 to the 0 is defined to be 1. 0 to the 0 is an exception. That's technically called undefined. You don't define it to be anything because it can lead to some inconsistencies. So we leave 0 to the 0 undefined, but any other number to the 0 power, by definition, is defined to be 1. Scratch your head, you wonder why. Why is that the case? Sorry about that noise there. Why is that the case? Well, like I said, I'm not going to explain why in this video, but if you try it in your calculator, it works. 5 to the 0 power equals 1. -17.584 to the 0 power equals 1. Let's see what happens if I try 0 to the 0 power in the calculator. 0 to the 0 power, error, domain. It's a problem, okay? Can't do 0 to the 0 power, but any other number to the 0 power is 1. Based on that, see if I can do this in a minute, I want to explain very quickly what we should define, for example, 2 to the -1 power to be. What should it be? So now I'm trying to define negative exponents real quick too and try to give you a brief reason. What should 2 to the -1 be? Well, here's the key. If I want the property of exponents that says, if I've got a situation like this, b to the m times b to the n, if I want that to be true even when the exponents could be negative, this should equal what I get when I add the exponents, -1 plus 1, which is 0, 2 to the 0, which is 1. This product should equal 1 if I want the rules of exponents to be consistent. Therefore, if I solve this equation for what I want to define this to be by dividing both sides of the equation by 2 to the 1st, that means 2 to the -1 should equal, and in fact does equal, 1 divided by 2 to the 1st power. Compare this with this. Divide both sides by 2 to the 1st power. it cancels, divides out over there, and on the right it becomes 1 divided by 2 to the first, or 1/2. 2 to the negative 1 should equal 1/2. Try it on your calculator. I guess I'll do it. It does work. I don't think I need parentheses here, but I'll put them in anyway for emphasis. 2 to the negative 1 power equals 0.5, which is 1/2. It really is what 2 to the negative 1 equals. And hopefully in the next video I'll have time to review that and explain it a little bit more, but I'd encourage you to think about that, what I just said in the last couple minutes there.